going to be a review of adding and subtracting fractions. And I have a particular format that I want you to use. So if you have not used this format before, it'll be particularly important for you to copy these problems very carefully. It just looks a little different than a way it is often taught in middle school. And so it's a way that's going to help you out in algebra. So we're going to start off with a pretty straightforward one, 3/5 plus 1/2. Now in middle school, a lot of times you rewrote this problem vertically like this, and you put equals across the side here. You found a common denominator. I hope this is looking familiar. The common denominator for 5 and 2 is 10, right here. And then you figured out what you had to multiply by to get that denominator. So there's different ways of showing that. Different teachers had different ways. Some people put an x here and a fraction. Other people put two x's like this, like you were multiplying the top and the bottom. Either one of those is okay. So 5 times what is 10 is 2. And if you multiply the bottom by 2, you had to multiply the top by 2. On the bottom one, 2 times what is 10 is 5. If you multiply the bottom by 5, you had to multiply the top by 5. And that gave you your new numerators. This is sort of the opposite of reducing fractions, which was covered in a previous lesson. So 3 times 2 is 6, and down here 1 times 5 is 5. You basically have taken a fraction that is already reduced and made it into an equivalent fraction that has the larger numerator and the larger denominator. So then you would go through and you would add your two numerators together, the 6 and the 5, and you would get 11, but you don't add the denominators, you leave the denominator alone, 11/10. Also in middle school, you usually change that to a mixed number, but I do not want you to do that, so do not change it into a mixed number. Now this format is fine, there's nothing wrong with it, but in algebra, a different format is going to be more useful. So I'm going to show you how this looks in a slightly different format, and I believe some of you have probably seen this already. When you look at the problem, consider what the common denominator is for the 5 and the 2. And make one big fraction and just put that denominator down one time. Don't put it down twice. The next thing is you're going to take this symbol, whatever it is, it's a plus, and you put it down. If it's a minus, you put it down and just put it right there, like that. And the next thing is to figure out what your two new numerators are. And you do that the same way as we did down in this area, only we're going to try to do it up here. So this is sort of a thinking thing. You say 5 times what gives you 10, and you either think or write 5 times 2, and then you would go up to the top and say then it has to be 3 times 2, and that's going to give me a 6. You're going to do the same thing for the second fraction. 2 times what gives me 10, and it's 2 times 5, and so you're going to say 1 times 5, and that's going to give you a 5. And you can see that you get exactly the same numerators writing it down this way that you got writing it the other way. It turns out that this method or this process of writing it down is just a little bit more useful for the subject of algebra. And then you work right across the page just like that, 11/10. 6 plus 5 is 11, just like you did when you worked in vertically. All right, so for all the rest of the examples, I will not be working them vertically. I'm going to be working them horizontally only. And that's the process that I want you to start practicing because it's going to make things a lot easier for you a little bit later on. All right, the next problem is 5/3 minus 1/2. Okay, so we're going to stop and think about a common denominator. And a common denominator for 3 and 2 is 6. So I write the 6 down once, nice big fraction across the top. And this time, because the problem is subtraction here, I'm going to put minus right here. All right, next I want to look at my first fraction and think, what did I multiply 3 times in order to get 6? And so I would have to multiply 3 times 2 in order to give me that 6. So I'm going to multiply 5 times 2, and that's going to give me 10, which goes right here. You don't have to draw all these arrows. Okay, then I'll switch to the second fraction. 2 times what is going to give me 6, and that's going to be 2 times 3 to give me that 6. So I'm going to say 1 times 3, and I'm going to put that number right here. This is looking very colorful. The last thing we do is we subtract the numerator, 10 minus 3, and 10 minus 3 is 7. We just copied the denominator down, and our answer is 7/6. Now, all of these lines that I'm drawing and all of the things where I'm writing down times 2 and times 3, those are not required. You can do that in your head. It is something that some people like to do. It helps keep them straight, but it is not required. All right, let's try another one. 1/4 plus 5x. Now, I'm going to work this problem twice because people will usually see this two different ways, and they're both correct, and I don't think one is better. One is a little faster if you see it, so I'll do that one first, but I want to show you the other way just in case. All right, we want to get a common denominator. Now, there are lots of common denominators for 4 and 8. You can use 4 times 8. You could use 32. You could use 16. But it's nice if you use the smallest one. If you can come up with the smallest one, then the work tends to be a little easier for you. So what is the smallest number that 4 will divide into, that 8 will also divide into? And that's going to be 8. That's going to make our life just a little bit easier with our arithmetic. Okay, put your plus here. And then I'll write this one more time. 4 times what is 8? 4 times 2. Therefore, I have to say 1 times 2, and I put a 2 right here. Now, in the second fraction, I didn't change the denominator. This denominator is 8, that denominator is 8. Therefore, that numerator is not going to change either. If you like, you can think of it as saying times 1. This is not going to change. And that gives us 2 plus 5 in the numerator, which is 7. And 7 divided, the denominator is 8, so our answer is 7/8. Now, I'm going to work this problem a second way, just because I've seen so many people do it this way. I want to make sure that you know that it's all right. So quite a few people have figured out or have learned that they can do this by always multiplying the two denominators together, saying 4 times 8. And that will work. You're just going to get a larger denominator, which means the arithmetic is a little bit, not harder, just a little bit bigger numbers, okay? And put your plus in the middle. And then if you do that, if you multiply the two denominators together, it's very easy to know what you have to multiply the numerator by. You multiply 4 times 8, so therefore you have to multiply 1 times 8, and that's pretty easy to do. Pretty easy to figure it out. You don't have to think about what to multiply by. Okay? What did you multiply 8 by to get 32? You multiplied it by the 4 right over here. So you just multiply the bottom times 4 and the top times 4, and you get 20. Now what happens when you don't get the smallest common denominator is you're going to end up with a fraction that can be reduced. Again, when I say reduced, I am not talking about changing it to a mixed number. I mean reducing them down to their lowest terms. So what number divides into 28 that also divides into 32? There are several. The first one I see is 2. That's the very first thing I see. So in my mind, I just want to, it's like plus. I'm just going to divide both of them by 2 because I can do that pretty easily. I don't really need a calculator for that. And then when I get that divided by 2, I can see that it divides by 2 again. So I'm going to go ahead and divide it by 2 again. Now that means it would have divided by 4 in the first place, if you had noticed it. So this way took just a little bit longer, but lots of people use it and there's absolutely nothing wrong with it. You do just have to make sure you get your answer completely reduced. Okay, let's do one more of these. The subtraction one. Okay, I'm gonna get that minus in there so I don't forget it. And I want to think about a common denominator. So you could use the common denominator of 9 times 6, these two things, multiply together, and use a common denominator of 54. You will get larger numbers, and you can do it that way, and that'll be all right. But I happen to see that there's a smaller one. What is it that 9 will go into, that 6 will also go into? When I can't see it, sometimes I make a little list. I take the biggest number, 9, and I start writing down its multiples. And I say, does 6 go into 9? And it does not. So I write the next multiple of 9, which is 18. Does 6 go into 18? And it does. And that's going to be my common denominator. Sometimes I do that when I'm not real sure what the denominator is. All right, so I've got my denominator, and then I stop and say, what do I multiply by to get that denominator? I multiply 9 times 2, therefore I multiply 10 times 2. You do the same thing to the top as you do to the bottom. That keeps them equivalent. Okay, what do I multiply the 6 times to get 18? 6 times 3, so I multiply 5 times 3. And this is subtraction, so don't say plus on it. Make sure you've written the minus down. 20 minus 15 is 5, and I get the answer 5 over 18 for my final answer. No calculator needed. Okay? All right, now what I'm going to do next is put in a problem that has a mixed number in it. And if you have not reviewed changing mixed numbers to improper fractions, you probably better go back and review that now to make sure that you know how to do it. Okay? All right, so the first thing I'm going to do is take this mixed number and I'm going to change it to an improper fraction. And I reviewed that in another video, so you can go back and look at that if you need to. I'm going to do that as a separate step. So this would be 2, the denominator 2 times the whole number 2 plus the numerator 1. 2 times 2 plus 1. 5, and you keep the denominator, 5/5. The second number is already an improper fraction. I'm just going to leave it alone. As soon as you do that one step, the problem looks just like the ones that we've already worked. I need a common denominator, and that denominator is 6 with my plus. 2 times what is 6 times 3, and so I say 5 times 3, and that gives me 15. 3 times what is 6? 3 times 2, so I say 4 times 2, and that gives me 8. And then I have to add 15 plus 8. And remember, no calculator, so use your fingers if you have to. 15 plus 8, 23 over 6. Double check when you get to the end and make sure you can't reduce that any. Nothing goes into 23 that also goes into 6. So we're through with that one. Okay, let's do one more of these. Okay, you have mixed numbers. In this, adding and subtracting with mixed numbers is easier if you change them to improper fractions first. So for this one, it's 5 times 4 plus 3, which is 23. So the first number becomes 23 over 4. And for the second one, it's 2 times 2 plus 1, which gives me 5, and I get 5 over 2. So those are my two new numbers. They are equivalent to the original problem. Okay, my common denominator, you could use 8, but 4 is smaller, so I'm going to use the 4, because it makes my life a little easier to use smaller numbers. And I'm going to put my minus here. I like to get that in there first so I don't accidentally write the wrong symbol there. Since this 4 did not change here, the 23 is not going to change. It's exactly the same. I don't have to multiply it at all. But for the 2, I had to multiply that by 2, so I multiply the top by 2 also, and I get 10. Then 23 minus 10, 13 over 4, and do not change them to mixed numbers. We are very happy with improper fractions in algebra, so leave it just like it is. Don't change it. Reduce it if it can be reduced, but do not change it to a mixed number. All right, last one. I want to work one that has a whole number in it instead of a mixed number. So we can just make sure you remember the first step in that process. Once we get the first step in, it works just like everything else we've done. If you have a whole number and a fraction, or a whole number and a mixed number, it's very helpful to think of that whole number as over 1. So instead of 8, we're going to think of it as 8 over 1. Give it a numerator and a denominator. Now I'm going to change my mixed number into an improper fraction. 3 times 5 is 15, plus 2 is 17, and that's going to give me the improper fraction 17/5. All right, so we have two fractions now, 8 over 1 and 17 over 5. Okay, my common denominator for 1 and 5 is 5. That's my favorite one. It's always super easy. I multiplied 1 times 5, so I multiplied 8 times 5, which gives me 40. This was already a 5. So I'm not changing it at all, so it's going to stay as 17. And now I have to say 40 minus 17. Now, generally, when I'm making you do these fractions, you're not going to have your calculator. If you have your calculator, I'll show you how to get the calculator to work these for you without having to write all this work down. Don't be afraid to go off to the side and do your subtraction on the side the way that you learned how to do it back in middle school and elementary school. You can write down 40 minus 17 on the side. You don't have to put it on scrap paper and throw it away. It's okay, just make sure it's neat. And do the subtraction over here. So remember, this becomes a 10, and that becomes a 3, so it's a 30 and a 10. And 10 minus 7 is 3, and 3 minus 1 is 2. So don't be worried if you have to write down a little bit of work to do your subtraction. Don't erase it. You don't have to ball it up and throw it away. That work can stay on your paper, and that will be fine. So there's a little review of how to add and subtract fractions, including mixed numbers.